There are two different types of logarithms. We have a common log, and then we also have a natural log. With that being said, the reason why we need logarithms is because we're dealing with exponentials. So if we have y equals 2 to the power of x, and that equals 10, your job is to figure out at what value of x is that going to be true. And if you do not have access to a graph of this, this might be a little bit harder to figure out. This is where logarithms come into play. Logarithms are used because we need to evaluate what is that x value. So let's just jump right into this equation here. I'm going to take off that y, which is no big deal. Don't erase it. Just leave it. It's not that big of a deal. So when we're dealing with this, we are using logarithms. So what this is saying is, going back to our properties of logs, just as a refresher, this x here has to come out, and then we'll use our logarithms with a common base of 10. Remember, I don't ever write anything, if it has a common base, I don't ever write it with the 10 there. So this is now x log 2 equals log 10. So from here, I can go ahead and rearrange this in order to get x by itself. I'm going to divide both sides by log of base 2, and then I'm going to calculate this. For our purposes, we'll want to round to, let's go 3 after the decimal, just make it a little bit easier. Sorry, grabbing my calculator, because I don't know the logarithms off the top of my head. Big thing with this, make sure you close your parentheses when you need to. And we'll get an approximation of 3.322 for this example. Now, sometimes you'll be asked, so this was going from exponential form into logarithmic form. Sometimes we'll go the reverse way. So let's say, for instance, we have log of base 5 of x equals 3. So let's see, refresher here. We are wanting to go into exponential form, so we got to make that e. So when we make our e, we go 5 to the power of 3 equals x. Now, this is just a simple calculation to take 5 cubed in order to get our x value. So we have 125 equals x. Now, remember that a logarithmic function cannot equal a negative number, so this is just something, just as a refresher, just to remember what that is. Now, we've been working with our common bases of 10. This example, I didn't use a common base, but just switching into exponential form. Sometimes there are other types of logarithms, and remember, that is our natural logarithm. So a natural log is in the form of log of base e. And remember, we write this as ln. Similar to what we've been doing here, same concept in terms of our logarithms when we had our other situation. Just a different definition. Some key things that you'll want to know here, in case you didn't know this: the natural log of 1 is 0. I should make that a bullet, not a negative. It looks like a negative sign. Gotta remember math terms here. The natural log of e equals 1, which makes sense. We're taking our base of e to the power of what number to equal e. If we have the natural log of y, this is going to be natural log of y. Natural log of e to the y, sorry, is going to equal y. And last but not least, if we have e to the power of the natural log of x, this is going to equal x. That e to the power of ln is going to cancel each other out. These are just some key features that you need to know. Same thing with if we have common logs, there's some common bases or common things that you can pick out. But realistically, you'll be dealing with the natural log a little bit more frequently in terms of that. So you'll be asked to have some of this information here and simplify it a little bit quicker. So for instance, you might be given, evaluate this if you have e to the natural log of 5. Well, using those key features that I just talked about, e to the power of ln cancels out and you're left with the answer of 5. So there's times when you'll be, using those shortcuts in order to evaluate logarithms a little bit quickly. Remember that e is really just a number. Just like pi, it's just a number. E is 2.718, just as a refresher. But otherwise, this is our quick evaluation for logarithms. I'll do one more example. I take that back. We'll deal with solving exponentials when it gets a little bit more complex after we've talked about the properties of logs and refreshed it.